Hi there, friends. This time I'm gonna show you one of my tools that I've used in my lab here. This here, it's a DAQ, a data acquisitor that I built like 8 years ago or something. The core of the circuit, it's a microchip PIC16F84, an 8-bit MCU. It also has a analog to digital converter on ADC 0804, an 8-bit analog to digital converter, and a max to 32 level converter to convert TTL levels to RS-232 levels. And using here an USB to RS-232 converter. So let me assemble this back together, and I'm gonna give example of how I acquired data, and this is a very handy tool. I'll pause the video and continue once this box is all assembled, because I took it apart to start the shooting. So give me a second and I'll play back here. Hold on. I can find the pause button. Okay, so the DAQ is all assembled, and I've connected a transducer to it. So I'm getting here 5 volts, the input signal to the ADC and the ground, and I'm using a cell phone charger as a power supply here. This is the power supply, just connected to the circuit, providing 5 volts. I'm gonna connect this to the power outlet there, and power's on the ADC. And the program running on the PIC reads the ADC and takes the 8 bits value and uses a binary code decimal. So it converts binary to binary code decimal, and then sends every digit serially. So it sends the units, then the tens, and then the hundreds. So the value can range from 0 up to 255. And then it sends a line feed and carriage return character. So this is the protocol I'm using. It takes a value, and then it uses a simple algorithm to convert binary into BZD, and then adds 48 to that. So it will start with characters 0, 1, and so on, and then it sends the units, the tens, and the hundreds, and then sends a carriage return line feed, and so on. So it does that every second, and the baud rate is 9600, 8 data bits and 1 stop bit with no handshake. So here every second you can see the LED on the USB to serial converter blinking. And here I've opened Hyperterminal, which is running at those settings, and you can see the value changing. Some background here. This is a manifold manifold absolute pressure transducer that came from my Opel Corsa. You can see here it's got let's see if I can get it here somewhere. It's got a GM brand marking. So this is here a pressure transducer. This is the inlet port, and then a hose is connected between this port and the throttle body. So it measures the air pressure or vacuum at the throttle body manifold. So I'm going to simulate the vacuum by using this medical syringe with a piece of rubber tubing attached to it. I'm going to plug this into the sampling port of the transducer, and you can watch the value changing here a little bit because there's a little pressure. When I insert the syringe, some air is compressed a little bit, so the value kind of jumps there. You can see the value here jumping. What I'm going to do here is I'm going to pull on the syringe, creating a vacuum, and you can see the value changing little by little. I'm going to pull this up, value decreases, and if I completely pull the syringe out, value drops to 43. I hope I can. Let me put this closer to the keyboard here, so I hope I can press any key here. So you can kind of the wire came loose here, so I don't have any assistance here. Actually, the connector detached from the unit. I use crazy glue, but I'll fix that later. Okay, that's why I got 0 there, because the transducer was detached. Okay, so I got, because the syringe is halfway out, and I'll glue this back together so there, so it kind of stays put. Okay, so the value is sent every second, and then since a carriage return line feed, that's why you're seeing this values flickering. Okay, so that's the fun part, and what I want to show you here is that I built a simple visual instrument in LabView. Let me get it here. It's got to be here. Oh, there. It's up there. Serial. Okay, so using LabView. Okay, so let me show you here. Okay, so that's simple here. Got a while loop here. So I'm using COM port 5 and the VISA service here. I use the VISA, take 5 here, port 5, and then I convert the value, and what I do here is I display the value on a waveform chart and a numeric display. But here, this 5 here indicates that I'm getting 5 characters every time from the serial port. So as long as the volume and there are no errors, the while loop continues to run. So the value comes from the VISA, and there's a switch on the VI, then an AND gate, and what I do here is just the error. If it's an error, then it will stop the while loop, and I'm getting 5 characters, and those characters are then displayed, converted to numeric value, and then a numeric value is displayed here, and then a waveform chart here. So that's pretty much the VI, very simple. So I'm gonna run it continuously there. I need to trigger this. It's running continuously on, see here again, and volume it's running. Okay, so the value is 150, and I'm gonna pull on this, and you can see the chart, hopefully, because it's getting dark here. So I'm pulling on the little syringe with one hand only, that's why I detached. So you can see the value dropping on the waveform chart, and I'll hold it there. So every second a value is sent, and you can read it on Hyperterminal or LabView or any other system. So it's the protocol is very simple. The value is sent in ASCII format and with a line feed and carriage return, and it will slowly let the syringe and the pressure will drop. So the value will increase here because the pressure is going to increase because the air on the top of the syringe is pushing on, and you can see the value changing. And I'm gonna push on here a little bit more, so the value rises to the top. So I just wanted to show you how a simple device like this, which is really inexpensive. I mean, it probably cost me, I don't know, this thing here cost me, I don't know, really, I guess less than 20 bucks. And this, of course, is a discarded, not really, it's a working MAP, just that I replaced it on my Corsa because I thought it was the reason why I was getting a data trouble code, but it ended up being the idle speed throttle valve, the idle speed regulator, and but I replaced it. So actually this is a spare unit. I actually sold the car already, so I have this around and I wanted to experiment with it. It's a vacuum pressure transducer. So let me show you again. I will slowly create a vacuum here by pulling on the syringe, plunger, a little like that. You can see the chart going down because pressure drops. So you can use this for, say, a process where you want to measure the vacuum on a certain circuit. Like if you want to measure airflow, you can put a Venturi tube and you can create an algorithm to indirectly measure the airflow using a vacuum line to connect it to the MAP, and you can measure the Venturi effect on the process. Oh, what was that? And it's a very useful, there, popped in there. So, well, that's all for now. Thank you for watching, and thumbs up if you like it. Bye.